folks. My name is Gordon Exel. I'm very happy to be here this afternoon. I actually have two roles, and I think you would have seen this in my bio. I'm chairman of the Natural Gas Vehicle Association in the United States. I'm a member of the global NGVA Association. And then I'm an executive with a company by the name of Westport. We're one of the global leaders in this space that I'm about to talk to you about. So I'm going to start with a bit of a US or North American view, and I will get global. I've been asked to talk about LNG and transportation, some of the opportunities and challenges, and hopefully I can get through this in the next 20 minutes or so. I thought I'd open with this slide. I think you might find it interesting. It could be one of the reasons that you folks would like to hear from me today. This is a look at the global transportation energy load. And as you can see, transportation in the yellow there is a big portion of the crude oil use globally. And then when you get over onto the right side, you start splitting up the transportation sector, and you see light-duty trucks, light-duty automobiles are the biggest user. Most of those would probably be gasoline, but some of them would be diesel. And then the one that I've got circled there is other trucks, and that's probably what I'm going to spend most of my time on. To get at light-duty vehicles, we need to deploy a lot of expensive stations globally. And the US pathway has been to focus on high fuel use applications where you don't have to put as many stations in, the investment's a little bit lower. And clearly trucks, a much lower population, a much higher fuel use application is a very good target. And so that's what I'm going to spend some time talking about. Fleets are obviously our target globally. At Westport, we have a joint venture with Cummins Engine Company globally, and then in China, we have a joint venture with Weichai Westport. So we do have a global footprint, but what we do find common from these fleets globally is this is a really challenging change for these folks to make. There are different engine technologies, and I'm going to actually take you through that in a moment, just explain a little bit about what those technologies do. The fleets need to decide on what kind of fuel they're going to use. CNG is very popular on this side of the Atlantic. LNG probably more popular in Asia and Europe, or will be. And then there's this emerging application for RNG, or renewable natural gas, and I will talk about that a little bit and just give you a feel for how we think that's going to impact the marketplace. Fleets need to decide what application they're going to target first. There's a lot of different options, as you can see in the top right there. Light duty into garbage trucks. Transit buses over here and in Europe are very popular, growing in South America and Asia. And then we're still working on that high horsepower sector, so mine trucks, rail, marine, light marine and heavy marine. And again, I'll talk a little bit more about that. And then how are you going to start this process? Are you going to take an existing vehicle and convert it, or are you going to buy a new vehicle from an OEM or an original equipment manufacturer? So there's a lot of decisions that fleets have to make. This is not an easy process. And over top of all that, this value proposition we have keeps on changing. So we've got that slide I just showed you and all the complexity with that. We also have to deal with, why should somebody make this change? And I thought I'd just show you over the last 6 years what's happened in the US. So across the top there, you see the size of the bubble there is really the value of that element. So economic value proposition in 2010 was significant because the price of crude oil was very high. And these things, our vehicles, were very easy to sell in the marketplace because the fuel was very inexpensive. In the US, there was a lot of talk about energy security, or abundance, or the lack of abundance of energy. And then this small bubble on the right, the environment, it was there, it was always present, but it wasn't really driving decisions back in 2010. Well, let's fast forward to today. The economic value proposition is very hard to find. You basically need funding, at least here in the US, to make this work. Abundance, well, energy security, it's still talked about, but with the shale plays both in oil and gas, there's a lot of energy available in North America. What has changed is this environmental footprint, the environmental importance, or carbon focus. And a lot of fleets globally are starting to look at this. And when they want to raise a sustainability flag from a corporate perspective, most of them are looking at the environment as the trigger to do that. So I mentioned RNG a couple of slides ago, or renewable natural gas. I am going to talk about this, and I know this potentially goes in conflict with what some of you folks do, but let me kind of walk you through a few slides to explain what we're trying to do here. So RNG, it's first and foremost, we found it in landfill gas. So what we were doing was taking that waste methane that was coming out of landfill sites and converting that into a vehicle fuel and burning it in our engines. Well, we've gotten a lot more sophisticated than that. This is a slide from a company called Redeem, which is a California-based RNG manufacturer, seller, if you will. And their process is, in this application here, agricultural, so capture the commodity or the raw stock, purify it, and then what they do is they actually, at that point, once it's clean, they drop it into the pipeline. But as they're doing that, they're actually selling those RNG molecules to fleets. So before that RNG molecule enters the gas pipeline, it's been sold to somebody. Now, I'm going to show you an example in a minute of who's doing a lot of this. And then whenever that company's truck pulls into a station, they don't get an RNG molecule, they've already bought that, but they just get a pipeline gas molecule, and they get the credit for that RNG molecule that they've bought. So again, I'm going to talk more about this because it has significant implications from a greenhouse gas perspective, and it allows us to leverage that growing environmental bubble. As I said, I'm going to have to talk a little bit about the technology here because the technologies do different things, and I think it's important you understand them. So bear with me here. A bit of an internal combustion engine seminar coming up on the two basic internal combustion engine platforms. First on the left, diesel cycle or compression ignition or diesel engine. What these systems do is they actually compress air until it's so hot that when diesel is injected under really high pressure, it ignites. It's a very efficient engine. That's why you see it in virtually all the heavy-duty trucks and high horsepower applications globally. Very fuel efficient, very performance-based. On the right, you see what's called the Otto cycle or spark-ignited system. And what it does is it compresses air a little bit, but then it has air and fuel mixed together and uses a spark plug to ignite it. The main difference between these two is probably the fuel economy benefit you see in the compression ignition or diesel cycle. Otto cycle, simpler engine, and you get some performance speed benefits out of it. But generally, you would see a fuel economy difference, and in fleets burning a lot of fuel, that's very important. So that's high-level internal combustion engines. Let's talk about natural gas engine technologies. There's a lot on this slide, but let me just start on the left. If you look at the bottom left, you'll see we start with light-duty vehicles, and then we sort of go up in weight classes here. Medium-duty, heavy-duty vehicles, so that would be an over-the-road tractor, trailer, truck, off-highway locomotives, sort of the beginning of high horsepower, and then large marine. And what you'll notice is that the fuel choice starts to shift. So light-duty virtually everywhere is CNG today. But as you move up in weight class, you start seeing a shift from CNG to LNG. The problem we have in the US is we started with CNG in the light and medium duty space, and so CNG is basically the dominant fuel in the US. We'll talk about other countries in a minute. But as you get into higher horsepower applications, you have to shift to LNG. You just don't have enough space on the vehicle to deal with CNG tanks. And then on the right, the technology choices. So the bottom right, spark ignited, that was the Otto cycle I talked about a moment ago. Today in the US, in trucking and busing, that is by far the #1 application. Probably in Europe too, and in China, this is a growing segment where you'd see spark ignited engines in diesel type platforms. Very simple, you just premix air and fuel in the air intake, and then you use a spark plug to ignite that natural gas and air. The one in the middle is dual fuel. I've added it because you do see it in the marketplace, mostly as a retrofit technology. So a fleet would have an existing fleet of trucks, and decide to enter into natural gas, they actually just cut a hole in the air intake, put a natural gas injector into that air intake, and so they mix diesel and natural gas, pull it into the combustion chamber, and that diesel ignites that natural gas in that compression stroke. The issue with this technology is today's capability gives you about 50% substitution. So you can run about 50% on natural gas, 50% on diesel. And when you're paying for expensive LNG or CNG tanks, you generally need a higher substitution to offset that, that cost. And so you see this around, it's not anywhere near as popular as the other applications. On the top, high pressure direct injection, it's my company's proprietary technology. It's going to be launched in Europe first. We actually had some product in the US, discontinued it. It was almost a retrofit type of system. We did that in partnership with Cummins. We are launching with a couple of European OEMs, and I'll walk you through that technology in a moment, but it gives you diesel-like fuel economy, diesel-like performance with natural gas as a fuel, and it's an LNG-based system. As I said, these technologies do different things. So at a high level, very simplistic view of this, the spark-ignited systems get you great reduction in oxides of nitrogen, or NOx. The high-pressure direct injection system gets you benefits from a carbon perspective or greenhouse gas perspective. So you end up with different choices, and again, adding to this complexity that we're giving these fleets. Spark-ignited, this is a schematic of what that system looks like. Both our systems here and in China look very similar to this. And what the key to this technology is the same thing that's been in the light-duty space for about 30 years. It's a catalytic converter or three-way catalyst. So this system allows us to get rid of very expensive, labor-intensive diesel after treatment and replace it with something that you're all familiar with. You just don't have to worry about it. It's a very reliable system. Catalytic converters are highly effective at managing NOx, and I'm going to show you an example of that. I think it's actually coming up next. Yes, it's here. So this is hard to read from here, but I think it's a 1985 bus, and the NOx line is what I'm going to focus on here, and I think it's got 10 grams per brake horsepower hour. That's the measure. You don't need to know what that means, but that's what the measure is. And that was in 1985, one bus. In 2010, EPA required all engines sold in the US to be 0.2 grams. Europe had a very similar measure just a couple years later. What that translates to is 54 buses were the equivalent of one 1985 bus. Well, with this technology that we have in North America, we knew we could use that catalytic converter to drive that number down further. And we've asked California and the EPA for an optional low NOx number, and that's what you're seeing here. It's 0.02, so 1/10 of the standard that's required today. It's optional, and if you use one of our new engines, you can actually get the equivalent of 540 buses compared to one 1985 bus. But in the process of developing this, we actually came in half that. We came in at 0.1. So you can see it's just a staggering difference over the years. What's important here is that 0.1, depending on who you talk to and what state or country you're in, from a NOx perspective, that's very close to what an electric vehicle would generate using upstream emissions captured. So there's calculations using RNG, which I'm going to talk more about in a moment, a low carbon fuel, and this technology that say you're as clean as an electric vehicle, which is really something because electrics are challenged in this space today, and I'll show you more about that in a moment. So that was spark ignited, very effective at NOx reduction, mostly in urban application. Where we're most active there on the planet is in Southern California because they have a huge NOx issue there, but it's any major city that has that clouded pollution is trying to deal with NOx. HPDI, this direct injection technology, so again, this one's shifting gears and more carbon focused. It's usually in larger horsepower applications. And in this scenario, well, in that first scenario, we build the engine, we ship the engine to an OEM, they put it in their vehicle. In this situation, we work with the OEM, use their engine, and it's fully integrated on their assembly line. The two core technologies here on the left, you'll see HPDI injectors. What we do here, a diesel injector under high pressure injects that diesel fuel into that combustion chamber. We have two ports, so we inject a drop of diesel and then natural gas under high pressure. That drop of diesel ignites with that pressurized air, and that then ignites the natural gas. A driver in this vehicle would be challenged to feel and notice the difference between this vehicle and a diesel vehicle, which is really important to them. Performance, fuel economy, everything will feel and seem the same. So as I said, launching in Europe first, we will expect to see it over here on this side of the Atlantic and in Asia. We're working with our joint venture partner there to launch this technology as well. But again, different target. It's a carbon-focused application. I thought I'd just put this quote in here. You wouldn't know, I doubt you know these folks, AVL, but they're the largest private engine integration engineering company in the world. They work with every global OEM and have a lot of influence, and you can read that first line there. The global regulators are continuing to challenge OEMs on fuel economy, which translates right into carbon. So as you improve your fuel economy, you lower your carbon footprint, and the diesel OEMs are going to be really challenged with the next set of regulations coming here first, but we think they'll be in Europe very soon. And AVL thinks this is the solution, which is an LNG-powered truck and other applications. Staying on this carbon benefit discussion, and I know this, I'm telling you from here, this is a very hard slide to read, but I'll talk you through it. California, very focused on this NOx reduction in Southern California, but they're also looking at fuel diversity. And I would say they're leading the world in this effort. And what they've done is created something called the Low Carbon Fuel Standard. And so on the left, you'll see that first blue bar on the left is actually diesel. I won't get into what the measure is. It's carbon intensity in a measure of fuel. And I believe that's 102 or 107. I can't see it from here, but that's baseline. And then we drop down from there. So then you have LNG delivered to a vehicle. CNG, they say, is lower, and this is looking downstream, upstream, the full life cycle of a fuel. They get into hydrogen and some other options in that center box, but what's interesting is that far right box gets into renewable natural gas. And so the first, sort of four in from the right is landfill gas converted to methane to run in vehicles or burn in these natural gas engines. Has a carbon intensity that's quite attractive. But as you go into the different feedstocks, you get into food waste, which is starting to get developed now in California, and you end up with negative numbers. There's a scenario in California where you're using the right feedstock and the right blend with LNG. So pipeline LNG blended with a renewable gas with a significant carbon benefit, you can end up with a negative number, negative carbon number in the fuel that you're burning. What we think we're going to have to do here is figure out some form of mix. The diesel folks used B20, which was 20% biodiesel, 80% diesel. We think will be something similar, maybe a B20 or B40 with biomethane mixed with LNG or CNG to give us an improved carbon footprint to leverage that value proposition that I put up a lot earlier. And this is capturing a lot of interest in the US right now, and I think it's going to capture a lot of interest globally very quickly. I mentioned I was going to talk about one fleet. This is probably the largest truck fleet in the world. UPS, certainly in the US, the largest truck fleet. They've been active in natural gas for a long time. They have been active with LNG trucks. They are the most active fleet in the US with LNG trucks. And they've just started to make this switch to RNG. So I'm not sure what their percentage is. I would guess 20 to 25% mix RNG and then the rest pipeline LNG. But they've been very successful with it, and they are by no means done. Their competitor FedEx has just opened the doors to this, and that's just the pressure that's, I think, being put on them by UPS. And I think we're just going to see that cascade effect where all of these large companies are going to be making this switch to leverage that value proposition. Okay, that was a US view. I thought I'd just take a moment here to give you a sense of what's happening globally. And I thought the best way to do that is talk about the Paris talks, COP21, that happened earlier this year. And then I'm going to zero in on Canada, because we've actually had some discussions with the Canadian government about a big problem they've got. And I think this table sort of summarizes it. So Canada, this month, will be submitting their action plan. They need a reduction of 30%, so a carbon reduction of 30% by 2030. And so what we did was we peeled the onion back on this and looked at transportation, and their action plan that they will submit, at least from 3 months ago, was going to show a 5% reduction in transportation by 2030, which means they are going to have to look to other sectors to find the support to manage this number that transportation is putting forward. We looked at passenger transport, so that's mostly light-duty vehicles, and that's the line right underneath that, and they're at minus 23%. Interesting, and we think probably electrics are going to help with that application, because electrics in lighter-duty passenger cars are doing the job today and will continue to do the job. At least that's our belief. That last one, heavy-duty trucks, not only is it growing by 34%, its submission will be positive 17%. So it's going to have to be heavily supported by other sectors in the Canadian economy to get to that 30% reduction. Really, it suggests that there is no solution in heavy-duty transport that the Canadian government has seen, which is why we stepped in with them. So we showed them a scenario where using LNG combined with RNG, if they replace, and I'm trying to see the number here, I think it's 6,000 trucks per year starting next year, they turn that 34% increase into zero. They can flatline it. And obviously, depending on how aggressive they get, they can do different things. But it shows a solution that the Canadian government could implement, and you can bet that this is a problem everywhere, because there just is no solution in heavy transport when you're talking about carbon. Battery technology is going to be really challenged to get there. Just a couple slides to close out. I did want to talk about batteries in a little more detail, because you see that happening in the light-duty space. It looks like it's having a lot of success. California has been desperately trying to get that market going and has heavily funded demonstration projects, and this is an example of those projects. Across the bottom axis here, you'll see Class 1, 2, 3, 4, 5, 6, 7, 8A, 8B. Class 1 is basically passenger cars, so it's light duty. Class 6 is where the red bar, the highest red bar is. There's over 200 vehicles being tested. Inner city trucks, sort of parcel, UPS parcel trucks, maybe larger ones, food delivery trucks. A lot of them being tested there. And then if you come to Class 8A, which is kind of buses, garbage trucks, not heavy trucks, but sort of the step below that, I think that's saying there were 17 tested. So we went and had a look at one of those. So this is a tractor trailer, electric, so it's using batteries. Down the middle, you'll see the metric. And so it's an interesting comparison. So let's just start with energy or fuel storage, comparing on the left, the battery vehicle versus a regular diesel truck. 300 kilowatt hours, 150 diesel gallon equivalents. I'm going to use gallon equivalent so we have a energy comparable here. And I think this might, this is in metric, most of this, so I apologize for that. Time to recharge versus refuel, 4 hours to charge those batteries, 5 to 10 minutes to fuel a diesel tank with fuel. Frame rail space, so this is how much space you have on a vehicle that has no space as you start. I mean, they are so tightly managed from a space perspective, and it's less than half the range, obviously, due to the battery, half the space needed for a diesel vehicle versus an electric. I think the thing that really kills this is the driving range. 160 kilometers versus 1,600 kilometers. It's just a non-starter in this industry. So technology, as it's currently set up today, just cannot function in this market. Tractor weight is very heavy because of the batteries, and when you put more weight on the vehicle, you can put less weight in the trailer, which is a big issue for the shippers. And then the vehicle cost, obviously, is quite dramatically different, 300 to 400K versus 100 and a quarter. So we don't see anything in the near future from a battery perspective that's going to make this change, and that's why we think LNG really is the fuel for the heavy-duty truck sector, and then as you go up into high horsepower applications, we think LNG is important there as well. Some of you are probably familiar with the ECAs, the marine ECAs, or emission control areas. They're driving major change, regulated change to shipping lines and vessels approaching shores, and we think, again, this is LNG is the fix for that challenge. One final slide to close. I talked about this earlier. If this is on the left, US CNG station data. It's about a month old. But 1,700 CNG stations, I can't quite see the number, I think it's 125 LNG stations. So in the US, one of the big issues is if you have an LNG truck, where do you go fuel it? You can certainly do LCNG, but we've got a big challenge here. I think where CNG has won from two perspectives so far. All the trash trucks and transit buses, which is where the US market started, are all CNG based. And so there was a lot of stations built to support those. The LNG pricing was the other issue, and so it was very visible. Somebody's selling CNG and somebody's selling LNG. The LNG was always priced higher. And it just, you're a truck driver or your fleet and you look at that and you just, boom, you go buy the more expensive CNG vehicle because the fuel's more expensive. And we're trying to work on that and make that shift. Europe's doing a bit of a different approach, or taking a bit of a different approach. They've got what they're calling the LNG blue corridor, so north, south, east, west. You're going to be able to drive trucks across Europe, and the European Union will make sure there's stations available to fill those trucks. So Europe has looked at this segment and said it has to be LNG. It's the only thing that makes sense, especially when you look at space-limited European trucks. So we think this will shift at some point. I think you folks could certainly be an important part of this discussion, but we need to see the U.S. starting to look at LNG more favorably to allow those heavy-duty trucks and other applications, high-horsepower applications, to dominate in this space.